When x centimeters cube of solution of 0.5 molar magnesium nitrate were reacted with ammonium carbonate solution, the mass of magnesium carbonate formed was 8.4 grams. Write the ionic equation for the reaction that took place. So the ionic equation, I want to write first the overall equation, then from there we will write the ionic equation. So this is magnesium nitrate, which is reacting with, we are reacting with ammonium carbonate, which is going to give us magnesium carbonate plus ammonium nitrate. This is a precipitating reaction. This is how we form insoluble salts. So magnesium is an insoluble salt as solid. This one is aqueous, and this one is aqueous. This one is aqueous. Let us balance the equation. We will put it to here so that we can balance the equation throughout. Now, this is not what we were asked to write. We were asked to write the ionic equation. We only write an ionic equation for the species that is forming the solid only. So the rest will be the spectator ions. So we just write what is forming the ions or the cations, and the anions forming the carbonate. The magnesium carbonate is magnesium and the carbonate ions. Therefore, ionic equation is that magnesium 2 positive aqueous plus the carbonate aqueous, which is forming magnesium carbonate as solid. So this is the expected response, and note this one. This one I was just trying to explain to you something. Calculate the value of x in this. So we want to calculate the value of x, but we have been given the mass of magnesium carbonate formed. If we have the mass of magnesium carbonate, we can get the number of moles of the sodium carbonate. So let us get the moles of magnesium carbonate formed equal to mass over RFM. Mass we have is 8.4 grams divided by the RFM. Magnesium is 24 plus 12 plus this, that is 84. So the number of moles is 0.1 moles. So this is the number of moles of magnesium carbonate formed. But from the equation you can see that the ratio for magnesium carbonate and the we want to calculate the and where is the, we want the X solution of magnesium. So we want to validate the magnesium nitrate. So we are comparing this and this. The ratio is 1 to 1. You can see the ratio is 1, 1. Meaning that the number of moles of magnesium carbonate, the number of moles of magnesium nitrate is the same. Since mole ratio of magnesium nitrate to that of magnesium carbonate is 1 to 1, moles of magnesium nitrate equal to 0.1. The ratio is 1 to 1. The ratio is 1 to 1. But we know that the 0.5 moles is the number of moles of magnesium nitrate in 1 liter, 1,000 centimeters cube. So we begin there. 0.5 is the number of moles of magnesium nitrate in 1 liter, 1,000 centimeters cube. We will ask 0.1 moles of the same will give us how many moles. So that one is 0.1 times 1000 divided by 0.5, and this one will give us 200 centimeters cube. So the value of X, the volume of magnesium nitrate that was used, is 200 centimeters. A certain carbonate, G carbonate, reacted with dilute hydrochloric acid according to the equation below. And this equation, we have been given the equation. The equation has been done for us. If 1 gram of the carbonate reacts completely with 20 centimeters cube of 1 molar hydrochloric acid, calculate the relative atomic mass of G. We want to calculate the relative atomic mass of G. So number of moles of HCl used, because the number of moles of this is HCl, we have the molarity of HCl, we have the volume, so we can easily get the number of moles of HCl that was used. We know that the one is the number of moles, which is in 1000 centimeters cube. We will ask 20 centimeters cube of the same will contain how much or how many moles. So that is 20 times 1 divided by 1000. It's going to give us 0.02 moles of HCl. So moles of HCl used is 0.02. So we can automatically get the number of moles of the G carbonate from the equation. We can see the ratio is 1 to 2. Mole ratio, that is the carbonate, the G, and the HCl is 1 to 2. So if the number of moles of the carbonate is twice, so the number of the carbonate is what? We are going to divide it by 2. So moles of the G carbonate is equal to a half times 0.02, which is equal to 0.01. But we want to calculate what? Calculate the relative atomic mass of G. So before we go at we must calculate first the RFM of G carbonate. So let me give you this triangle. I've always given this triangle. We have more. Okay, we have these moles. We have RFM. We have mass. Now we have the number of moles of the G carbonate. We want RFM. We have the mass, right? So RFM of the G carbonate equal to moles from here. RFM is equal to mass over moles. Mass over moles. Mass over RFM is equal to mass over moles. Mass is 1 divided by moles, which is 0.01. So the RFM is 100. Now, since we have the RFM, meaning that G carbonate, when you add every mass of each element, the answer should be 100. So G plus 12 plus 16 times 3, which is 48, will give us 100. G plus 60 will give us 100. So G equal to 100 minus 60, and that is 40. So the relative atomic mass of G is 40. When a hydrocarbon was completely burned in oxygen, 4.2 grams of carbon 4 oxide and 1.71 grams of water were formed. Determine the empirical formula of the hydrocarbon. You have been given the relative atomic masses of each. So first we know an hydrocarbon. So we have carbon 4 oxide formed. We have water formed after burning an hydrocarbon. But we are not interested with carbon 4. This what we are interested is carbon and hydrogen, because an hydrocarbon is an organic compound which contains carbon and hydrogen only. Therefore, let us get the mass of carbon from carbon dioxide. We get the mass of hydrogen from the water. So carbon itself is 12 over the total carbon, that is 12 plus 32, that is 44, and then times the total mass, which is 4.2. Now this one gives us the mass of carbon, and this one is going to be 1.145 grams. Similarly, let us get the mass of hydrogen from water. So water is, the total mass of water is 18, and hydrogen, there are 2 of them, so 1 plus 1 is 2. So 2 divided by 18 times the total mass, which is 1.71, we will get hydrogen, and the mass is 0.19 grams. Now we have the mass of carbon and the mass of hydrogen. Now we go back, element, the element here is carbon, another one is hydrogen. Mass in grams. Carbon is 1.145, hydrogen is 0.19. The next thing is the RAM. RAM of carbon is 12, hydrogen is 1. The next thing is the number of moles. How do you get moles? Moles is mass divided by RAM. Mass divided by RAM. RAM here, or RAM. So we have 0.095. This divided by this, you get 0.19. The next thing we want to calculate is the mole ratio. So the mole ratio, we divide by the number of moles which is smallest. So this one is smallest, is smaller than this one. Therefore, 0.095 divided by 0.0, we will get 1. Here we will get 2. So it means that carbon was 1 of it and hydrogen was 2, and that is the empirical formula of the hydrocarbon that was required. D gram of potassium hydroxide were dissolved in distilled water to make 100 centimeters cube of solution. 50 centimeters cube of solution required 50 centimeters of 2 molar nitric 5 acid for complete neutralization. Calculate the mass D of potassium hydroxide. Relative formula mass of potassium hydroxide is 56. So we have an equation here. The good thing is that you have written that you have made our work easier by writing the equation for us. So we know that 50 centimeters cube of nitric acid, which has a molarity of 2, required 50 potassium hydroxide for complete neutralization. But now, since we have the molarity of the nitric acid, the volume, this is where we begin. We get the molarity, the number of moles that reacted. We say that 2 is the number of moles of nitric acid that are contained in 1000 centimeters cube. Now we want to ask 50, the volume that was used, will contain how many moles of nitric acid. So that is 50 times 2 divided by 1000. That one will give us 0.1 moles. Right? As you can see, the ratio from our equation is, the ratio is 1 to 1. The ratio is 1, 1, 1 everywhere. Meaning that, so mole ratio is 1 to 1. Meaning that moles of nitric acid will be equal to the moles of potassium hydroxide. So moles of potassium hydroxide equal to 0.1. Moles of potassium equal to 0.1. Right? So 50 centimeters cube of potassium hydroxide contains this number of moles, but the solution that was prepared, it is 100 centimeters cube. So let us get the number of moles in 100 of solution D, which is potassium hydroxide. So we will say 0.1 is the number of moles which are contained in 50 centimeters cube. What about 100 centimeters cube of the solution will contain how many moles? So it is 100 times 0.1 divided by 50, and this one will give us 0.2 moles. Now we have the number of moles of the solution that was prepared. Now the next thing is to calculate the mass. How do you get mass? Mass is equal to moles times RFM. The moles of the potassium hydroxide is 0.2, and the RFM we are given 56. So this times this will give you 1.2 grams. Next question. 20 centimeters cube of solution containing 4 grams per liter of sodium hydroxide was neutralized by 8.0 centimeters cube of dilute sulfuric acid. Calculate the concentration of sulfuric acid in moles per liter. In moles per liter. I want to do this for you in using two methods. So I will start with method number 1. So method 1. Method 1. First, as we know, every equation, every chemical reaction, write the equation, balance it for you to get the ratio, the mole ratio. That's the most important thing. So let us write the equation. Sodium hydroxide is reacting with sulfuric acid. Sodium sulfate plus water is formed. We will balance the equation. Now 4 grams is in 1 liter, so we will say 4 grams of sodium hydroxide was made in 1000 centimeters cube sodium hydroxide. We will want to know the mass in 20. So 20 centimeters cube will contain because the volume that was used is 20 centimeters of this was used. So we will get the mass, that is 20 times 4 divided by 1000, and that one will give us 0.08 grams. So this is the mass that was used. Now since we have mass, we can get the number of moles of sodium hydroxide. So moles of sodium hydroxide, is given by mass of RFM. The mass is 0.08 and the RFM is 40. RFM is 40. And this one will give us 0.02 moles. Right? Now the ratio for sodium hydroxide and sulfuric acid, because remember the question is asking us calculate the concentration of sulfuric acid. Now we have the number of moles of sodium hydroxide that reacted with sulfuric acid. Since the ratio is 2:1, now we can get the number of moles of sulfuric acid. Now moles of sulfuric acid equal to, I have this number of moles, this one I have 0.02 times I have, and that one is 0.01, because the ratio is 1 to 2. Now we have the number of moles of sulfuric acid, but we know the volume of sulfuric acid that was used was neutralized by 8 centimeters cube cube dilute sulfuric acid. So we know this number of moles is in 8. So 0.01 moles of sulfuric acid are contained in 8 centimeters cube of volume. What will be the number of moles in 1,000 centimeters cube? Because we want concentration, molarity, concentration in 1 liter, moles in 1 liter per liter. So it is 1,000 times 0.01 divided by 8, and this one will give you 0.125 capital M. That is the molarity. Let us go to method 2 and see. Method 2, let us use this triangle here. Molarity RFM mass in grams per liter. Now we have the mass in grams per liter. 4 grams was dissolved to form a liter. Now we can calculate the molarity of sodium hydroxide used. So molarity is equal to mass which must be in grams per liter divided by R FM. We know the mass, that was 4 grams, and the RFM is 40. So the molarity of this sodium hydroxide that reacted with sulfuric acid is equal to 0.1 capital M. 0.1 capital M. Yes. Now next, we can now calculate the number of moles of sodium hydroxide that reacted with sulfuric acid. So we know the molarity of sulfuric acid. So we will say 0.1 is the number of moles of sodium hydroxide that are there in a liter, 1,000 centimeters cube. We will ask 20 centimeters cube will contain how many moles. So that one is 20 times 0.1 divided by 1,000, and that one is giving 0.002 moles. So this is the number of moles of sodium hydroxide that reacted with sulfuric acid. But from the equation we saw, the ratio is 1 to 2. So mole ratio of sodium hydroxide to sulfuric acid is 2 to 1, meaning that moles of sulfuric acid is equal to a half of this, 0.01 moles. So then we are going to say that 0.00 moles are contained in 8 centimeters cube of sulfuric acid. 1,000 centimeters cube will contain how many moles? 1,000 times 0.01 divided by, where did I get this one? This one is divided by 0.01. Yeah, there is a 0 here, 0.1. 0.01 divided by 8, and that one will give us 0.125.